Welcome to Noah Science, where Saturn rings and moons reveal beauty built from ice and loss. Before details appear, the system hangs in darkness like something finished, though nothing here stays stable. Saturn looks serene, yet its symmetry hides a world whose most beautiful features are already unraveling. Those famous rings are not eternal. They are thinning, falling inward and dying on planetary timescales. Even now, pale ring rain drifts toward the planet, turning elegance itself into a slow descent. Saturn begins far from the Sun, where cold distance and shortage decide whether giants can form. Beneath the clouds lies an older victory, where solids gathered first and gave the planet structure. Saturn survives by growing fast enough before the young Sun clears the disk and ends construction. Because Saturn holds itself more loosely than Jupiter, its compromises softness and fragility show more clearly. That weaker grip becomes a guide, letting hidden tensions rise outward into shape motion and loss. The bands are only weather, while the planet sinks downward through pressure, heat, and chemistry. Saturn spins so quickly that motion reshapes the globe, stretches its bulk, and strengthens immense winds. From afar, the rings seem singular, but nearby they become collisions, gaps, ice, and restless order. As the ring plane widens, distant moons begin to matter, turning ornament into a governed family. Saturn's true power appears through its moons, where Titan, Enceladus, and smaller worlds rewrite the system. On Titan, rain rivers and seas return in alien form, giving chemistry a second familiar world. Enceladus should be frozen shut, yet it throws ocean material into space and breaks silence. Across the system, gravity makes harmony expensive, trading order for tides, stress capture, and erosion. What we see is not final design, but a temporary arrangement still assembling, shifting, and fading. Saturn feels eternal only because we are brief, while its beauty gains meaning by disappearing. Like, subscribe, and thank you for listening, as Saturn first appears calm and begins deceiving us. Saturn is the most elegant lie in the solar system. From far away, it looks complete, balanced, ceremonial, a planet so perfectly adorned that it seems less like a world than an idea of what a world should be. A golden sphere, a flawless ring, a geometry so clean that even people who know almost nothing about astronomy can recognize it instantly. That is the surface impression Saturn gives to the human mind: order, calm, permanence, grace. But the story on the surface is smaller than the story underneath. Saturn is not the solar system's monument to stability. It is one of its clearest monuments to fragility. The obvious explanation is that Saturn is beautiful because it is serene. The real explanation is harsher. Saturn is beautiful because we are catching it in the middle of an arrangement that is temporary, violent, and beginning to come apart. Nearly everything that makes Saturn iconic depends on motion imbalance, collision, erosion, and loss. Even its stillness is an illusion created by distance. Move closer, and the calm vanishes. The cloud tops race with winds that can outrun the storms on Earth. The planet spins so quickly that it bulges outward at the middle, as if rotation is trying to tear roundness itself into a wider shape. The rings that look like solid bands from afar dissolve into fragments of ice and dust, each piece following gravity, colliding, shifting, and slowly surrendering altitude. The moons are not decorative companions. They pull, disturb, shepherd, fracture, and reshape the system. What looks from Earth like a finished masterpiece is in reality a machine made of restless parts. Saturn occupies a special place in the imagination because it is large enough to feel mythic, distant enough to feel untouchable, and strange enough to keep defeating the first explanation offered for it. It is the second largest planet in the solar system, vast enough that more than 700 Earths could fit inside it by volume, and yet so low in average density that it would seem absurd if it were not true. It is a giant made mostly not of rock or metal near the surface, but of hydrogen and helium materials, more associated in the human mind with stars and atmospheres than with anything solid enough to deserve the word planet. Saturn appears to be a place, but in many ways it behaves like a layered event. There is no simple boundary where the world begins in the way a shoreline announces the beginning of an island. There is no familiar surface waiting beneath the clouds, no stable ground hidden just below the haze. Descend into Saturn, and the world does not resolve into something simpler. It becomes more compressed, more pressurized, more alien as gases become liquids. Liquids become deeper metallic states, and the distinction between atmosphere and planet starts to fail. This only looks simple from a distance. Even its color deceives. To the eye, Saturn seems soft pale, a muted world of honey ash and cream. Yet that subdued beauty covers a place assembled under the brutal economics of planetary formation, where matter had to gather fast in the cold outer reaches of a young solar system before the raw materials of creation were blown away. Saturn exists because it formed in time. It remains what it is because gravity never stops negotiating with heat spin and orbital force. Its rings exist because something was broken or prevented from becoming whole. Its moons exist because some material escaped that fate. Its present elegance is built on past disruption. This is why Saturn is such a powerful subject. It tempts the mind toward the wrong conclusion first. Jupiter overwhelms by mass. Mars invites comparison with Earth. But Saturn seduces through appearance. It looks like order made visible. It looks as if nature once decided to make something ornamental. Yet the real Saturn is not ornamental at all. It is structural. It is historical. It is a record of formation and destruction written in hydrogen ice and gravitational stress. The rings are not an accessory attached to the planet. They are evidence. The moons are not secondary details. They are witnesses. The atmosphere is not a pretty veil. It is a barrier hiding the deeper architecture below. And once that becomes visible, even conceptually, Saturn changes character. It stops being the serene jewel of astronomy posters and becomes a planetary system that exposes how beauty can emerge from instability without ever escaping it. Human beings are vulnerable to timeless-looking things. If something appears balanced, we imagine it has always been so, or should remain so. Saturn exploits that weakness perfectly. The rings look eternal because they are thin, broad, and luminous in black space. The globe looks settled because it turns in silence. The whole planet seems to occupy a realm beyond weathering and decay. But planetary systems do not care what looks eternal to a brief observer. They care about energy, momentum, resonance, collision rates, tidal stresses, migration paths, and time. On those terms, Saturn is not a frozen symbol. It is a temporary arrangement. Its atmosphere is in motion. Its moons are in negotiation. Its ring particles are being ground-sorted and in some cases pulled inward. Its shape is not fixed by dignity, but distorted by speed. Its story is not the story of a completed object. It is the story of an immense compromise held together for now. And that final phrase matters most for now. Because once Saturn is understood, not as a perfect planet, but as a living balance of competing forces, one feature rises above all the others as the clearest expression of that truth. The rings do not merely surround Saturn, they reveal it. They are the reason the planet became famous, and they are also the reason the deeper story turns darker. The most recognizable structure in the outer solar system is not permanent, not secure, and not safely preserved for the far future. Saturn's greatest beauty is also its most vulnerable confession. The crown is real, the calm is not. And the closer we look at those shining bands of ice, the more Saturn stops looking eternal and starts looking like a world caught in the act of losing the thing that made it unforgettable. The most famous thing about Saturn is also the thing Saturn cannot keep. The rings look too perfect to be temporary. They appear like architecture, as if some hidden cosmic engineer laid bright bands around the planet with geometric care and left them there for eternity. From Earth, they seem stable enough to serve as a symbol. In illustrations, logos, textbooks, and memory, Saturn is the ringed planet, as if the rings are part of its identity in the same permanent way. Mountains belong to Earth, or a crust belongs to a moon. But the rings are not a permanent possession. They are a dwindling event. The obvious explanation is that Saturn has rings, because Saturn is the kind of planet that has rings. The real explanation is narrower and far less forgiving. Saturn has rings now because at some point in its history, a large quantity of icy material ended up trapped in orbit within a range where it could not gather into a moon. And since then, that material has been colliding, spreading, sorting, and slowly being lost. The rings do not simply exist. They are being processed. They are being eroded. They are, in a meaningful planetary sense, dying. This is the first major break between human intuition and celestial reality. Human beings are trained by everyday objects to think that visible structure implies durable structure. A crown made of metal endures. A road remains where it is laid. A disc stays a disc unless something tears it apart. But Saturn's rings are not solid surfaces. They are not smooth sheets. They are not even one object. They are made of innumerable particles, many dominated by water ice, ranging from dust-sized grains to chunks as large as houses, or larger, all moving on separate orbits, all obeying gravity, all constantly interacting. From a distance, the rings look like a singular form. Up close, they are traffic. They are weather without air. They are a flattened swarm of debris forced into order by orbital motion and prevented from becoming something simpler. Every particle is falling around Saturn. None of them are resting. None of them are safe from collision. And crucially, none of them are guaranteed permanence. The rings survive only by motion. That makes them beautiful. It also makes them vulnerable. For a long time, the age of Saturn's rings remained one of the great uncertainties of planetary science. Did they form with Saturn itself billions of years ago, left over from the planet's birth? Or are they comparatively young, the aftermath of a shattered moon, a disrupted comet, or some later catastrophe? The answer is still not absolutely settled in every detail. And that uncertainty matters because it changes the emotional scale of what we are seeing. If the rings are ancient, then they are survivors of extraordinary resilience. If they are young, then humanity has the astonishing luck to live during a brief luminous episode in Saturn's longer history. What matters here is not that every argument is finished. It is that the old assumption of permanence has already failed. Evidence gathered over decades, including close observations from spacecraft points toward a ring system that is active, evolving, and losing material. Saturn's gravity does not simply hold the rings in place, it also helps destroy them. Tiny ring particles become electrically charged by solar radiation or are disturbed by impacts and interactions. Some spiral inward, some get kicked into new paths, some are pulled along magnetic field lines and rain into the planet's upper atmosphere. This process is often called ring rain, a phrase almost too gentle for what it means. It sounds poetic. It is actually a leak in one of the solar system's grandest structures. Material from the rings is slowly falling into Saturn. The planet is consuming the feature that made it iconic. The achievement is real. The cost is larger. Once that becomes clear, the rings stop looking like a static ornament and start looking like a reservoir under depletion. And depletion is only part of the problem. The rings are also being ground down from within. Their particles collide again and again, sometimes softly, sometimes destructively changing speed, fragmenting edges, redistributing energy, and altering the fine structure of the system. Moons and moonlets carve gaps, stir waves, and confine sharp boundaries. Resonances impose order, but that order is not peace. It is managed tension. Some regions clump, some spread, some brighten because fresher ice is exposed, some darken as dust accumulates. The rings are full of pattern, but pattern here does not mean stillness. It means force made visible. And the closer one looks, the more the rings resemble not an eternal band, but a battlefield so delicately flattened that violence masquerades as symmetry. This is why Saturn's rings are scientifically precious. They are not just spectacular to look at. They are a natural laboratory for orbital dynamics, collision physics, and the border between making moons and unmaking them. There is a critical region around a planet where tidal forces can prevent loose material from assembling into a single larger body. Cross that boundary under the wrong conditions, and a moon can be torn apart. Remain inside it as debris and particles can circle for ages without ever being allowed to complete the transition into something whole. The rings may be the long echo of one such failure. Perhaps a moon ventured too close and was broken. Perhaps a comet or icy body was disrupted and spread into orbit. Perhaps several events contributed over time. The precise origin remains debated, but the deeper lesson is already visible. The rings exist because some matter around Saturn did not get to become what gravity usually prefers. Gravity often wants to build. Here, it also destroys. Saturn's beauty is born from that contradiction. A structure millions of kilometers wide may owe its existence to something being prevented from finishing its own formation. This only looks decorative from a distance. In truth, the rings are a record of interruption. They are a monument to the difference between orbiting and belonging. And because the system is losing material, because the particles are interacting, because the planet and its moons are constantly reshaping the debris, the rings are not simply evidence of an old catastrophe. They are an ongoing countdown. Not a countdown in human time, not something vanishing before the next sunrise, but not an immortal feature either. Given enough time, the rings as we know them will thin, fade, fall, reform in altered ways or disappear. Saturn will remain. Saturn with these rings will not. That is the crucial emotional reversal. The very thing that makes Saturn seem timeless is what proves it is not. The symbol is temporary. The icon has an expiration written into its mechanics. And once the rings are understood as unstable debris rather than everlasting design, a harder question emerges beneath them. If Saturn's most visible feature is not primordial certainty, but the outcome of broken material and constrained orbit, then the deeper mystery is no longer how the rings stay beautiful. It is how Saturn itself came to exist in the first place so far from the Sun. in a region where building any giant world at all should have been slower, colder, and much less likely than the finished planet now suggests. Saturn should have been harder to build than it looks. Seen from the present, it feels inevitable, as if a giant ringed planet simply belongs in the outer solar system, waiting at the proper distance, like a piece placed correctly on a board. But planets are not assigned positions. They are assembled under pressure inside a disk of gas and dust that does not wait forever. The familiar image of planetary formation is too calm. Dust drifts, pebbles gather, worlds emerge. It sounds patient, almost gentle. The real problem is not whether matter exists. It is whether enough of it can be gathered quickly enough in the right place before the entire construction environment begins to vanish. Saturn forms far from the Sun in a region colder than the inner solar system and more diffuse in raw material per unit volume, where orbital times are longer, collisions are less frequent, and every success in growth has to fight against delay. This only looks easy after the fact. The farther one moves from the Sun in the early solar system, the more the nature of the game changes. Close in high temperatures prevent volatile compounds from freezing, so the building materials are dominated by metals and rock. That makes terrestrial planets possible, but it also limits how much solid mass can accumulate. Farther out, beyond what planetary scientists call the frost line conditions, become cold enough for water and other volatiles to freeze into ice. Suddenly, the young disk contains more solid material that can participate in growth. That sounds like an advantage, and it is. It is one reason the giant planets do not form near Mercury and Venus. But the advantage arrives with a cost. Distance reduces speed. Material circles the Sun more slowly. Encounters happen over longer timescales. The disk is larger, thinner, and more spread out. The environment provides more potential building blocks, yet makes them harder to collect. Saturn emerges inside that contradiction. It forms where there is finally enough cold material to build something large, but also where time works against assembly. That tension is the beginning of the real story. The obvious explanation is that Saturn is a gas giant because it is made of gas. The deeper explanation is that before Saturn can become a giant wrapped in hydrogen and helium, it must first win a race to build something much less glamorous, a massive core capable of forcing the surrounding nebula gas to stay. Without that early success, Saturn never becomes Saturn. It remains a failed beginning, a scattered population of icy bodies, a larger version of nothing completed. This is one of the hardest conceptual turns in planetary science, because giant planets look like atmosphere and behave like gravity, but their existence begins with solid accumulation. Small grains collide and stick. Pebbles cluster into larger aggregates. Kilometer-scale planetesimals form and begin to dominate their local regions. Gravity amplifies the winners. The larger an object becomes, the better it becomes at gathering more material both through direct collision and through its growing gravitational influence. But there is nothing automatic about this process. Impacts can build and break. Objects can scatter one another rather than merge. Gas drag can alter orbits. Migration can move bodies inward and outward. The young solar system is not a clean workshop. It is a crowded, turbulent, time-limited construction zone. And Saturn forms in the part of that zone where missing the window means missing it completely. Because the gas in the protoplanetary disk does not last. The Sun is not yet the quiet star it will later become. In its youth, it is wrapped in the same disk that feeds planet formation, while radiation winds and internal evolution gradually strip that gas away. Astronomers looking at young star systems today find that these disks are temporary features. They endure for millions of years, not forever. That may sound generous on human terms. In planetary terms, It is brutal. To become a giant planet, Saturn must assemble a core large enough, fast enough, to begin drawing in hydrogen and helium before the reservoir is gone. Miss that deadline, and the opportunity collapses. The planet might still exist as a large icy or rocky body, but not as the low-density giant now orbiting the Sun. Saturn, in other words, is not just a product of available material. It is a product of timing under scarcity. And timing is where the outer solar system becomes merciless. Jupiter, closer in and probably forming earlier, likely reaches critical mass more effectively and more quickly, allowing it to gather an even larger gaseous envelope. Saturn follows in a different regime, where the remaining conditions still allow giant planet formation, but less decisively. That difference matters. It may explain why Saturn becomes immense, but not dominant. Massive, yet markedly less massive than Jupiter, rich in gas, but less able to hold the solar system in gravitational obedience. Saturn is not simply the second giant. It may be the giant that reveals how narrow the path really was. The farther one looks into its origin, the less it resembles inevitability, and the more it resembles survival through a narrowing corridor of possibility. There is another complication. Planets do not necessarily stay where they are born. Modern models of solar system evolution suggest that migration likely reshaped the early architecture of the giant planets. Interactions with the gas disk and later with swarms of planetesimals may have moved the planets inward or outward from their original positions. That means Saturn's present location may not be the exact place where its growth began or reached its decisive threshold. The story on the surface is that Saturn lives at about 9.5 astronomical units from the Sun. The deeper story is that early giant planets may have wandered while the solar system was still fluid, their gravity rearranging smaller bodies and one another in the process. Saturn may therefore record not just formation in the cold outer disk, but formation amid migration, changing density fields, altered feeding zones, and shifting competition. The system beneath the planet is larger than the planet itself. Saturn is not merely a world that condensed where we find it now. It is a survivor of an evolving disk, whose structure, temperature, and dynamics were all changing while the planet was trying to become real. This is why Saturn matters scientifically beyond its beauty. It sits at a crucial threshold between excess and incompletion. Too little core growth and it never captures enough gas. Too much delay and the disk disappears first. Too much competition from Jupiter and its feeding zone is disturbed. Too much movement and local supply changes. Yet despite all of that, Saturn emerges as a world of immense scale one whose envelope of hydrogen and helium announces success while quietly concealing how conditional that success was. It is easy to admire the finished planet and forget the fragile sequence that made it possible. But the finished planet is misleading. Saturn exists because the early solar system briefly permitted a very specific chain of victories: solid growth beyond the frost line, rapid core assembly, timely gas capture, and continued survival in a system not yet settled. The elegance we see now is the late appearance of a much rougher beginning. And once that becomes clear, another reversal follows immediately. Because if even a giant planet of gas must begin with hard accumulation and buried structure, then Saturn's visible size stops being the main mystery. The deeper question becomes what lies underneath that vast atmosphere. What kind of hidden foundation had to form first? And how much of the real Saturn is still concealed below the clouds we mistake for the planet itself? The planet people imagine when they imagine Saturn does not really exist. What they picture is a globe of clouds and color, a giant atmosphere with rings attached, as though Saturn were mostly surface appearance wrapped around empty scale. But gas giants are deceptive in a specific way. They look like worlds without foundations. The obvious explanation is that Saturn is a vast ball of hydrogen and helium, and that everything important about it follows from that fact. The real explanation begins lower down. Before Saturn can become a giant of gas, it must become a winner in the hidden contest of structure. It must build something dense enough, massive enough, and early enough to force the surrounding nebula to give up its light elements before they are lost. Saturn does not begin as a cloud. It begins as a buried argument for permanence. The visible Saturn is the consequence. The invisible Saturn is the cause. In the early solar system, a forming giant planet cannot simply drift through the gas and grow by abundance. Hydrogen and helium are plentiful, but they are also hard to keep. A young object needs enough gravity to bind them enough mass to deepen the well and enough time before the disk disperses. That requires a core, or at least a region of concentrated heavy material assembled from rock ice and the debris of many collisions. The exact internal architecture of Saturn remains an active scientific question. Whether it possesses a sharply defined compact core, a more diffuse core partially mixed into surrounding layers, or something in between, is still debated. That uncertainty matters because it reveals how misleading the word core can be. Human language suggests a clean center, a hard ball at the middle. Saturn may be messier than that. Its deepest layers may grade rather than divide with heavy elements, blending outward instead of stopping at a neat boundary. But the deeper point survives all versions of the model. Saturn is not merely gas made large. It is a planet whose enormous atmosphere depends on an interior enriched by heavier material, the residue of early accumulation and the anchor of later growth. What matters is not the precise line where the core begins. It is the fact that Saturn has depth in both structure and history. The atmosphere is only the latest layer of a much older achievement. Saturn is physically immense, but its scale alone does not explain its existence. Plenty of matter may circle a star without ever becoming a giant planet. To cross that threshold, a forming world must reach a point where its gravity no longer gathers only solids efficiently, but begins to seize gas as well. Once that transition starts, growth changes character. The planet's envelope thickens. The pressure in the interior rises. Heat accumulates. Infalling gas and planetesimals release gravitational energy. More mass permits more gas capture. More gas capture increases gravity. A threshold becomes an avalanche. But avalanches only happen if the slope was built first. Saturn's hidden heavy interior is that slope. Without it, the atmosphere we see would never have arrived. This is why Saturn's low density, often treated as a curiosity, is actually part of a larger story. Yes, Saturn is the least dense planet in the solar system. Yes, its average density is lower than that of liquid water, but average density conceals as much as it reveals. Saturn is not light in any ordinary sense. Its total mass is still enormous, about 95 times Earth's. Its low mean density comes from composition and size, from hydrogen and helium, spread over a vast volume, not from any lack of internal seriousness. Beneath the cloud tops, pressures rise to levels no terrestrial intuition can comfortably hold. Hydrogen, so familiar on Earth as a simple gas, is compressed into states that do not resemble the laboratory version of the element. Deeper down, it can become metallic, able to conduct electricity under colossal pressure. Somewhere below the visible atmosphere, the distinction between gas and liquid becomes less meaningful, and Saturn changes from a world of weather to a world of compressed fluid layers wrapped around its hidden heavy interior. The planet you see is not the planet you get. The cloud tops are not a shell covering empty softness. They are the highest visible edge of an enormous pressure system organized by gravity all the way down. If Saturn formed by building a substantial concentration of heavy elements first, then the present planet preserves evidence of the early solar system inside its body. Its atmosphere is not a random blanket. Its composition, internal heat, and distribution of mass contain clues about the materials available during formation and the violence of assembly. Even Saturn's excess heat matters. The planet radiates more energy than it receives from the Sun, a reminder that giant planets are not passive recipients of sunlight, but active worlds still releasing internal energy from formation and differentiation. Helium may slowly separate from hydrogen in deeper layers and fall inward like a planetary rain, releasing more heat as it sinks. What looks placid from afar is still settling itself from within. Human beings see a stable globe. Physics sees a stratified body, still redistributing energy, still carrying the memory of formation in its interior, still revealing through gravity and chemistry that the visible planet is only a fraction of the real story. A terrestrial world teaches the mind to think in surfaces, crusts, and solid boundaries. Saturn erases those comforts. Its foundation is buried beneath layers that thicken, compress, and transform until the categories of everyday matter begin to fail. The deeper one goes, the less Saturn resembles the image that made it famous. The ringed sphere of the imagination gives way to gradients. Metallic hydrogen hidden heat, uncertain core structure, and a planet whose true architecture is mostly inaccessible to sight. Beauty once again turns out to be the shallowest layer, and once the hidden Saturn comes into view, another asymmetry becomes impossible to ignore. Because Saturn does not merely hide its structure beneath clouds, it also reveals by comparison with Jupiter that giant planets built by similar rules can still end up profoundly different, and that Saturn's very looseness may expose truths the larger world next door conceals more effectively. Saturn is not the product of perfect formation. It is the product of formation completed just in time. That distinction matters because giant planets are often described as if scale alone explains them, as if enough materials simply existed in the outer solar system and gravity patiently did the rest. But giant planets do not arise from patience. They arise from deadlines. The obvious explanation is that Saturn becomes immense because the young solar system provides vast stores of hydrogen and helium for any growing world to collect. The real explanation is that those stores are temporarily unstable and brutally easy to lose. Saturn only becomes Saturn because it reaches the necessary mass threshold before the protoplanetary gas disk begins to vanish. It is not the story of unlimited growth. It is the story of a narrowing opportunity seized before the window closes. That is a different kind of triumph. In the first few million years after the Sun forms, the solar system is not yet the clean arrangement of planets, moons, and empty space that later generations inherit. It is a busy, gas-rich, dust-filled disk, luminous with leftover heat, dense with the materials of construction still violent with movement. This is the only era in which a giant like Saturn can truly be made. Once the gas is gone, the chance to build a low-density envelope of hydrogen and helium on Saturn's scale goes with it. Rocky worlds can still collide and grow. Icy bodies can still scatter and merge. But the distinctive architecture of a gas giant depends on an early environment that does not last. The gas disk is both the source of Saturn's future body and the timer counting down against its formation. That makes Saturn less a simple planet than a successful emergency. The deeper one looks into this problem, the clearer the tension becomes. To capture large amounts of gas, a forming planet must first accumulate enough heavy material to create a gravitational well, deep enough to hold the nebular envelope. But gathering that heavy material takes time, especially so far from the Sun. Orbital periods are longer. Matter is more spread out. Every merger is slower to arrange. Every missed collision costs more. Saturn therefore faces a contradiction at the heart of its existence. It forms where there is enough frozen solid material to make a giant possible, yet also where the slowness of the outer disk makes giant formation harder. If it grows too slowly, the gas escapes into space or is blown away by the changing young sun. If it grows quickly enough, it can cross a critical threshold and begin accreting gas much more efficiently. Saturn exists because it reaches that threshold before failure becomes final. Saturn is not what happens when growth proceeds normally. Saturn is what happens when growth outruns disappearance. Jupiter makes this timing problem even more revealing. Because Jupiter likely reaches critical mass earlier, it not only claims more gas for itself, but alters the surrounding disk through its own gravity, reshaping the environment in which Saturn must continue to form. The giant planets are not isolated projects built in separate workshops. They are competing outcomes in the same evolving system. Jupiter's presence may redirect flows of gas, disturb the motion of solids, and change the feeding conditions available farther out. Saturn, therefore, does not merely race against the clock of disk dispersal. It may also race inside an environment already being modified by a larger and faster rival. This is one reason Saturn is so scientifically revealing. It is not the largest success. It is the narrower one. It shows what giant planet formation looks like when the path remains open but not comfortably open. Saturn becomes enormous, yet not dominant. It claims a vast gaseous envelope, yet not one comparable to Jupiter's total command. It is the planet of qualified victory, and those qualifications expose the system more clearly than perfection would. Even after Saturn begins pulling in gas, the process is not guaranteed to continue smoothly. As the planet grows, it heats. That heat can slow further contraction of the envelope. Gas dynamics around the forming planet become complicated. Material may spiral inward through a circumplanetary region, some feeding the planet, some helping build its future moon system. Migration through the disk may alter what material remains accessible. The larger Saturn becomes, the more it begins to change its own growth conditions. Success creates turbulence, growth creates resistance. The world becomes possible because early accumulation works, then remains incomplete, because the same system that enables giant formation also limits it. Saturn does not become a star because it never comes close to the mass needed for hydrogen fusion. It does not become Jupiter because the disk does not keep offering easy abundance forever. What emerges is neither a failed planet nor an unlimited one, but a giant frozen at the scale permitted by timing competition and exhaustion. The planet is huge. The permission was temporary. This has an important emotional consequence. Saturn's softness, its low density, its broad atmosphere, even its visual gentleness, all tempt the mind toward the wrong metaphor. It looks like overflow, like a world made from surplus. In reality, Saturn is a world made from urgency. It gathers what it can while conditions still allow it, then the door closes behind it. Saturn reaches giant status before that transition becomes irreversible, but it carries the mark of incompletion inside its success. It is large, yet not maximized, stable, yet born in instability, majestic, yet fundamentally contingent. The story on the surface is that Saturn is a grand outer planet. The story underneath is that Saturn is what a giant looks like when it wins late enough for the struggle to remain visible. And that visibility matters, because once Saturn is understood as a world shaped by timing and partial completion, rather than by effortless abundance, another comparison becomes unavoidable. Jupiter may be the greater giant, but Saturn's lower mass, weaker grip and looser structure make its compromises harder to hide. In Saturn, the giant planet blueprint is still there, but the seams show more clearly, and the next step in the descent is to understand why that looseness reveals more about the fragility of giant worlds than sheer dominance ever could. Jupiter is the larger giant, but Saturn is the more revealing one. Human instinct usually mistakes magnitude for importance. The bigger world seems like the deeper story. The heavier planet appears to be the truer expression of giant planet power. By that logic, Jupiter should be the cleaner example of how gas giants work, because it is more massive, more gravitationally commanding, more obviously dominant in the architecture of the solar system. But dominance can hide as much as it displays. The obvious explanation is that Jupiter, by virtue of being greater, tells us more about giant planets than Saturn ever could. The real explanation is subtler. Jupiter is so successful that some of the tensions of giant planet formation and survival disappear beneath its strength. Saturn, by contrast, is still immense, but not overwhelming. It is giant enough to preserve the full drama of this planetary class, yet loose enough that its compromises remain visible. Jupiter is a triumph so complete that it can look inevitable. Saturn is a triumph still carrying the marks of the struggle. That makes Saturn the more transparent giant. Start with mass, because mass controls everything that follows. Jupiter contains more than 3 times Saturn's mass. That extra weight does not merely make it bigger in a casual sense. It deepens the gravitational well, strengthens the compression of the interior, intensifies the planet's hold on its atmosphere, and gives it a broader authority over nearby matter. Jupiter's success at becoming a giant world is so decisive that it hardens the whole category in the human mind. We imagine gas giants as worlds that gather vast envelopes and keep them worlds with atmospheres so deep and gravity so commanding that nothing essential is left exposed. Saturn refuses that simplification. It is still immense, yet its lower gravity makes its atmosphere less tightly bound, its average density lower, its internal compressions somewhat less extreme, and its system more legible as a set of negotiated balances rather than a single overwhelming fact. Jupiter tells the story of victory. Saturn tells the story of what victory costs when it is not absolute. This is why Saturn's density matters more than it first appears. It is easy to treat the famous comparison to water as a novelty, a scientific party trick repeated because it sounds impossible. But the lower density is not just a curiosity. It is an outward sign that Saturn is built with a looser grip on itself. The difference between Jupiter and Saturn is not simply that one is bigger. It is that Jupiter's additional mass changes the internal conditions enough to produce a more forcefully compacted world, while Saturn remains more expanded, more vulnerable to shape distortion, and more revealing of how much of a gas giant's identity depends on pressure doing the work gravity demands of it. Saturn is what a giant planet looks like when structure is still under obvious negotiation. Its very silhouette tells the story. It bulges more strongly at the equator because it rotates rapidly and lacks the mass needed to suppress that distortion as completely as Jupiter does. The planet is not just spinning fast. It is visibly admitting what speed does to a body that large when gravity is immense but not supreme. Even the winds participate in this revelation. Saturn's upper atmosphere hosts extraordinary jet streams and storms, including flows that can exceed those on Jupiter in speed. That alone is already destabilizing to the picture of Saturn as the gentler giant. The softer-looking planet is not the quieter one. It is, in some respects, the more visibly dynamic one. Jupiter's atmosphere impresses through power and scale, but Saturn's atmosphere often exposes the tension between motion and containment more clearly. That difference is not accidental. It grows from the same underlying reality. Saturn has enough mass to build giant complexity, but not enough to bury every sign of its own delicacy. The same comparison extends outward into the planetary systems each world governs. Jupiter has rings too, but they are faint and relatively insubstantial, easy to forget beside Saturn's broad luminous display. That contrast is not merely aesthetic. It reminds us that Saturn's lower gravity and different collisional history permit a far more conspicuous ring system to persist in a visible form, even as that ring system advertises instability rather than permanence. Saturn wears its fragility openly. Jupiter hides more of its debris. Saturn turns debris into identity. The moons deepen the contrast further. Jupiter's major moons are monumental and varied, but Saturn's system possesses a particular kind of interpretive richness because the planet itself does not dominate the story quite as completely. Around Saturn, Titan and Enceladus do not merely orbit a giant, they reshape how the giant is understood. Titan carries a dense atmosphere and active surface chemistry unlike anything else in the solar system outside Earth. Enceladus, tiny by comparison, vents material from a hidden ocean into space. In Saturn's domain, the satellites are not just subordinate objects. They become essential chapters in the meaning of the whole system. That, too, reflects Saturn's more revealing nature. Jupiter is so commanding that its family can seem to radiate outward from its power. Saturn, while still central, allows the structure around it to remain more visibly collaborative, more system-like, less swallowed by a single massive personality. This does not make Saturn weak. It makes Saturn interpretable. A gas giant is not defined only by how much matter it has, but by how that matter distributes energy, deforms shape, governs satellites, constrains rings, and exposes internal structure through external behavior. Saturn becomes precious because it sits at the point where giant planet grandeur and giant planet vulnerability coexist in full view. It is large enough to be mythic, yet not so complete that the seams vanish. It is powerful enough to command moons, rings, weather, and deep internal compression, yet not so overpowering that those components stop being individually legible. In Jupiter, giant planet success reaches a scale that can blur the mechanism beneath it. In Saturn, the mechanism keeps showing through. The deeper one looks, the less Saturn resembles a lesser Jupiter, and the more it resembles the key to understanding what giant planets actually are when stripped of easy symbolism. They are not just big. They are layered compromises between mass and motion compression and expansion capture and loss. Saturn makes those compromises visible. That visibility changes the emotional meaning of the planet. Saturn is not the runner-up giant. It is the giant that lets the observer see the category itself. It reveals that even planetary enormity can be contingent, that even a world made mostly of the lightest elements can be burdened by structural tension, and that beauty can become clearest where power is slightly incomplete. But there is still one major deception left intact. Because even after Saturn is recognized as the more revealing giant, the human eye remains trapped by the same mistake that began the descent, the belief that what is visible is what matters most. And on Saturn, that illusion becomes more dangerous than ever, because the bands storms haze. And soft gold light we call the planet are not really the planet in the ordinary sense at all. They are only the shifting upper skin of a much deeper hidden system waiting below. What most people call Saturn is not actually Saturn in the fullest sense. The eye sees bands haze storm's subtle color, a smooth globe of pale gold wrapped in rings, and it assumes that what is visible is the planet itself. That assumption is natural. On Earth, the visible surface is where the world becomes real to us. Mountains, oceans, deserts, ice sheets, coastlines, all the things that let the mind say, this is a planet and here is its face. But Saturn has no such face. The obvious explanation is that its cloud tops are simply the outer appearance of a giant world, the equivalent of a surface painted in wind and light. The real explanation is more disorienting. The visible Saturn is only the thin upper threshold of a vast atmosphere so deep, so compressed, and so continuous with the interior below that the comforting distinction between weather and world begins to break down. We do not look at Saturn and see the planet. We look at Saturn and see the highest layer that light can reach before the real planet disappears beneath pressure, opacity, and depth. This matters because the atmosphere is not decoration. It is concealment. Saturn's upper clouds are made largely from compounds that condense at different levels under different temperatures and pressures, including ammonia, ice, ammonium, hydrosulfide, and deeper water clouds far below direct view. Saturn is not neatly layered like a textbook diagram, with each band patiently waiting beneath the last. Its atmosphere is dynamic, turbulent, mixed by convection, shaped by rotation, and driven both by energy from the sun and by heat still leaking outward from the planet's own interior. The world shines softly, but it does not rest softly. Winds tear around the planet at extraordinary speeds. Storm systems can grow to enormous size. At the North Pole, Saturn hosts a hexagon-shaped jet stream, so persistent and so geometrically strange that it looks almost artificial at first glance. Yet even this astonishing feature is not the heart of the story. It is only another clue. The atmosphere reveals motion while hiding cause. We can watch patterns. We can track clouds. We can measure temperatures, chemistry, and wind speeds. But the deeper one asks why the atmosphere behaves this way, the faster the visible world runs out and the hidden one begins. Saturn's rapid rotation is part of that hidden machinery. A day on Saturn lasts a little more than 10.5 Earth hours, meaning a world nearly 10 times Earth's diameter spins with astonishing speed. That rotation stretches the planet outward at the equator, flattens it at the poles, sharpens jet streams, and helps organize the atmosphere into broad bands. But rotation alone is not enough. Internal heat rises from below, driving convection from depths inaccessible to direct sight. Chemical layers condense and evaporate at different altitudes. Pressure climbs relentlessly downward. What looks like a gentle planetary skin is really the visible turbulence of a deep fluid body responding to gravity, heat, spin, and composition all at once. Saturn is not a ball-wearing weather. Saturn is a weathering body all the way down, until even the word weather becomes too small. This is where human intuition begins to fail completely. On Earth, going downward means eventually reaching ground. On Saturn, going downward means entering a continuum of increasing pressure, where gases thicken, boundaries blur, and familiar states of matter surrender their ordinary meaning. There is no clean point where one can say the atmosphere has ended and the real planet has begun. The story on the surface is that Saturn has clouds above a planet. The deeper truth is that the clouds are the upper expression of the planet. Descend far enough, and hydrogen ceases to behave like the airy substance known from balloons and laboratory bottles. Under crushing pressure, it becomes a dense fluid. Deeper still, it may enter metallic phases, conducting electricity and helping generate the magnetic field. Somewhere beneath all of that lies the enriched deep interior, perhaps, with a diffuse core rather than a sharply bounded center, perhaps layered by gradients, rather than divided into textbook shells. But none of this is available to the eye. Saturn hides itself not because it is distant, but because its very nature is opaque. Light tells us about the top. Gravity, magnetic field spectra, and careful modeling must tell us about the rest. This makes Saturn one of the clearest examples in the solar system of a world whose true structure can only be inferred. The pale gold planet of human memory is real, but only in the way a skin is real. It tells us something, but not enough. It gives texture without foundation. It offers movement without depth. It is the visible edge of a reality much larger than itself. Even the colors are a partial truth. Saturn's muted tones result from atmospheric chemistry, scattering haze, and the relative absence of the stronger contrast seen on Jupiter. That softer appearance encourages an emotional misreading. Saturn seems calmer because it looks quieter. It seems simpler because its colors are more restrained. In fact, the soft palette may simply mean that the turbulence is being filtered through layers and hazes that suppress dramatic contrast. The obvious explanation is visual. The real explanation is atmospheric. Once again, Saturn turns beauty into misdirection. The very thing that makes it feel gentle is part of what prevents us from seeing what is really happening. Because if the visible planet is only the topmost flicker of a far deeper fluid world, then Saturn's true identity is not fixed by what sunlight reveals from afar. It is shaped by the internal motions that connect clouds to depth rotation, to distortion chemistry, to heat and surface appearance, to unseen architecture. The planet is not a picture, it is a process. And once that becomes impossible to ignore, another harder insight follows immediately. Saturn's atmosphere does not simply hide the planet's interior. It also shows through its shape and behavior that the whole world is being physically deformed by motion itself, that Saturn is not even the simple sphere it pretends to be. And that spin has written its influence into the very body of the planet. Saturn only looks calm because human eyes are bad at seeing motion that never stops. A planet hanging in darkness appears still by default. It seems to occupy space like a statue, holding a shape that feels natural simply because it persists. But Saturn's shape is not natural in that passive sense. It is negotiated by speed. The obvious explanation is that a planet is round because gravity pulls matter inward from every direction until a sphere emerges. That is true, but only until another force becomes large enough to interfere. Saturn rotates so quickly that roundness itself begins to fail. A day there lasts only a little over 10.5 Earth hours. For a world of Saturn's size, that is astonishing. The result is visible distortion. Saturn bulges strongly at the equator and flattens at the poles, making it one of the oblate bodies in the solar system. The planet is not merely spinning. It is being reshaped by the fact that it spins. This is the moment where Saturn stops feeling like an object and starts feeling like a contest. Gravity pulls inward, rotation throws outward. The sphere survives only as a compromise between them. Once a planet rotates, this quickly, motion stops being a surface detail and becomes an organizing principle of the whole world. The atmosphere responds first. Winds accelerate into jets. Cloud bands become expressions of rotational control rather than random weather. Storm systems are stretched, confined, and redirected by spin. The strange hexagon at Saturn's north pole is the most famous reminder of this, a six-sided atmospheric wave so enduring that it feels almost impossible when first seen. But the hexagon is not the central mystery. It is a symptom. Saturn's atmosphere is not wandering freely across a blank globe. It is being guided by a rotating system that channels motion into preferred lanes and boundaries. Even the chaos is disciplined. Yet the real problem is not atmospheric. It is internal. Because when a giant planet spins this fast, the distortion is not confined to the cloud tops. It extends downward into the mass distribution of the planet itself. Saturn's equatorial regions sit farther from the center than its polar regions, because rapid spin reduces the effective pull of gravity there. Matter responds. Layers adjust. Pressure balances shift. The whole world becomes less a simple stacked sphere and more a rotating fluid body whose interior must answer to both compression and centrifugal effect. This matters because giant planets are not rigid. Saturn does not resist deformation the way a rocky planet would. Much of its volume is fluid or behaves like fluid under planetary conditions, which means rotation can write itself into the body of the planet far more deeply. The visible flattening is only the outside of a deeper rearrangement. The planet's internal layers, their densities, their boundaries, even the way energy moves through them, all exist within that spinning frame. Saturn is not built first and rotated second. Saturn is what its matter becomes under rapid rotation. Once that becomes clear, another misunderstanding collapses with it. Human beings tend to think of rotation as a measurement, a line in a data table, 10.5 hours. But abstraction weakens consequence. The real significance is physical. Saturn spins so rapidly that the equatorial diameter is thousands of kilometers larger than the polar diameter. That is not a decorative detail. That is a planet admitting that motion has altered its architecture. The same principle exists on Earth, but far more modestly. On Saturn, it becomes undeniable. The achievement is real. The cost is structural. And because the planet is made largely of hydrogen and helium elements that compress and flow under enormous pressure, rapid rotation helps create a world in which even defining the internal rotation rate becomes difficult. Different latitudes in the atmosphere can rotate at different apparent rates. Magnetic field measurements, radio emissions, wind tracking, and interior models do not always align neatly. Saturn spins so effectively that it complicates one of the simplest questions a person could ask about a planet. How long is its day exactly? Motion has become so fundamental that even timekeeping grows uncertain. The deeper reason is that a gas giant does not present a single solid reference surface. One layer shears against another. Winds move relative to the deeper interior. The magnetic field may be aligned in ways that conceal rather than clarify the internal rotation. Saturn once again resists the first explanation. Even its day is not as straightforward as its image suggests. This only looks like a round world turning quietly in sunlight. In truth, it is a rotating fluid machine whose shape, weather, internal stresses, and observable ambiguities all flow from speed. And speed changes meaning at scale. A spinning top on a table is a toy. A spinning world nearly 10 times Earth's diameter becomes a different category of reality. At Saturn's equator, points in the atmosphere race through space at extraordinary velocity, simply because the planet is turning beneath them. That motion feeds the dynamics above and reflects the structure below. Rotation helps maintain the banding. It sharpens the flattening. It influences how heat escapes. It participates in how mass settles over time. The planet's beauty once again emerges from tension rather than peace. Saturn appears balanced because the forces deforming it have reached a working arrangement, not because those forces are absent. A stable-looking world can still be under constant dynamic strain. Saturn's shape is not evidence that motion has ended. It is evidence that motion has won a place inside form itself. And once form is understood as the visible record of spin, the next step in the descent becomes unavoidable. Because rapid rotation does not only distort Saturn's body and organize its atmosphere, it also helps explain why the rings, which seem like a single clean band from afar, are nothing of the kind. Around a planet, this dynamic nothing stays simple for long. The rings are not a static halo completing a graceful sphere. They are another rotating system fractured into countless parts governed by collisions, resonances, and shifting boundaries. And the closer one looks, the less they resemble decoration, and the more they resemble a crowded society of ice under permanent orbital pressure. From Earth, Saturn's rings look like a single gesture, an oval, a clean band, a smooth extension of the planet's elegance, so continuous and symmetrical that the human mind compresses the whole structure into one idea, the ring. That singular word is already a mistake. The obvious explanation is that Saturn is surrounded by one magnificent object, unified and complete. The real explanation is stranger and far more alive. Saturn's rings are not one thing. They are a vast, flattened system of countless separate pieces, each following its own orbit, each obeying gravity, each colliding, shifting, clustering, scattering, and being reorganized by the planet and its moons. What appears as a single shining band from away becomes up close a crowded society of ice under permanent stress. To understand the rings properly, one has to abandon the idea of a surface. There is no continuous sheet suspended around Saturn like a disk of polished glass. There are particles, mostly water ice, ranging from tiny grains to larger fragments, all sharing roughly the same orbital plane, but not the same exact speeds or positions. Particles closer to Saturn travel faster than particles farther out. The ring system cannot behave like a rigid object without tearing itself apart. It survives precisely because it is not solid. It is divided into pieces that can move at different velocities while still participating in the larger flattened structure. The rings look unified because distance erases detail. In reality, they are a dynamic arrangement maintained by motion, not a single body preserved by rest. Even the major named rings, the A, B, and C rings, and the fainter structures beyond them, are not neat compartments in the way a diagram suggests. They are regions with different particle concentrations, different brightness, and different histories of disturbance. Some areas are dense and brilliant. Some are thin and dusty. Some contain waves and gaps shaped by gravitational interactions. Some are being eroded or contaminated by material from elsewhere in the system. The labels are useful because human beings like boundaries. Saturn does not care about our boundaries. Its rings are full of gradients, resonances, and local negotiations. They are structured, but not static. They are organized, but only because organization is being continuously forced out of motion and collision. This is why the rings are far more violent than their appearance suggests. Violence in space does not need fire to count as violence. It only needs energy, impact, and relentless consequence. Ring particles strike one another constantly. Many collisions are gentle by cosmic standards, but gentle repeated billions of times is still transformative. Impacts can chip surfaces, redistribute momentum, alter orbits, and turn larger fragments into smaller ones. Dust is created. Ice is exposed. Regions flatten, diffuse, sharpen, or brighten. A ring system is not simply a pile of debris that happened to stop changing. It is debris that cannot stop changing. The particles are too numerous, too mobile, and too entangled in one another's paths. Saturn's rings persist not because they are untouched, but because constant interaction keeps remaking the visible order. And then there are the moons. In practice, the moons help write the rings into the forms we see. Small moons embedded near or within the ring system can disturb nearby particles, opening narrow gaps or creating edge waves. Larger moons farther out impose resonances that repeatedly tug on ring particles at predictable locations, sculpting spiral density waves and other patterns into the disk. Some tiny moons act like shepherds, helping confine narrow ringlets and keeping them from spreading away into diffuse debris. The metaphor of shepherding sounds peaceful, but the physics beneath it is strict. These moons do not protect the rings out of kindness. They constrain them through gravity. The ring system is therefore not merely a cloud of leftovers circling Saturn. It is a negotiated structure produced by planet-wide and moon-wide influence, with every gap, ripple, and boundary, recording a history of orbital pressure. The famous Cassini division, which once looked like a simple empty break between two major rings, is not truly empty. It is another reminder that even absence in Saturn's rings is structured rather than clean. The deeper astronomers look, the less the rings resemble a finished object, and the more they resemble a language of interactions. The gaps are not blank spaces. They are outcomes. The waves are not decorations. They are evidence. The ringlets are not delicate threads hung in darkness. They are temporary concentrations inside a field of constant rearrangement. This changes the emotional meaning of the rings completely. They stop being a static ornament and become a visible map of forces that are usually invisible. Gravity writes in curves. Collision writes in dust. Resonance writes in spacing. Time writes in erosion. Because the rings are so broad and so thin, they exaggerate the illusion of precision. Seen edge-on or from a great distance, they look almost like one mathematical line. But their thinness is itself part of the tension. The particles occupy a remarkably flattened orbital plane, yet within that plane there is endless local complexity. Saturn does not wear a finished crown. It wears the shape of a perpetual process. And because the process depends on collisions, moon interactions, and the slow loss of material, the rings are not a solution. They are a temporary equilibrium under pressure. What matters is not the ring as symbol. It is the ring system as behavior. Once that becomes clear, Saturn changes again. The planet is no longer merely the world with the rings. It becomes the center of a complex gravitational society in which debris can act like architecture. Moons can act like sculptors, and beauty can be the visible consequence of endless low-grade destruction. But that realization opens a larger door. Because if Saturn's rings are not a self-contained ornament, but part of a broader dynamic system, then the next question is no longer about the rings alone. It is about the family around the planet, the moons that disturb and reveal it, and the possibility that Saturn's deepest significance may not lie in the globe or the rings at all, but in the worlds orbiting nearby that transform the ringed giant from a single spectacular object into a miniature solar system of its own. Saturn is not really one world with accessories. It only looks that way until the moons begin to speak. From a distance, the planet dominates the imagination so completely that everything else seems secondary, as if the satellites are little more than decorative companions orbiting a larger central marvel. That is how giant planets are often misread. The obvious explanation is that the rings define Saturn and the moons merely surround it. The real explanation is wider. Saturn becomes fully intelligible only when it is seen not as a planet wearing ornaments, but as the center of a complex planetary family in which the moons help reveal the history, structure, and meaning of the entire system. The globe is immense. The rings are famous, but the moons rewrite the story by showing that Saturn's deepest significance does not lie in its beauty alone. It lies in what its gravity has organized, preserved, transformed, and in some cases quietly activated over billions of years. This is the transition from object to system, and it changes everything. A large planet does not merely hold satellites by accident. It creates an environment in which many different worlds can emerge, survive, migrate, collide, become captured, or be broken into new forms. Saturn's moon system is one of the richest in the solar system, not just in number, but in variety. Some are small, irregular bodies, battered and dark, more like remnants than finished worlds. Some are icy, mid-sized moons, whose surfaces preserve ancient scars and strange tectonic patterns. Some interact with the rings, directly carving gaps, stirring edges, or acting as gravitational shepherds. And then there are the moons that refuse the role of secondary objects entirely. Titan, Enceladus. Even before their details are understood, their existence already forces a reframing. Saturn is not important only because it is a giant planet. It is important because it governs a domain where radically different kinds of worlds can coexist under one gravitational order. This matters more than it first appears. Human beings are drawn to central objects. We like the star more than the planet more than the moons, the capital city more than the provinces. But nature is not obliged to place its greatest revelations at the center of a system. Sometimes the largest body sets the stage while the deeper surprises appear in smaller actors nearby. Saturn is one of the clearest examples of that principle. The planet provides mass gravity, tidal influence, radiative environment, and a long-term orbital architecture. The moons respond differently depending on size, composition, distance, internal history, and dynamical interaction. What emerges is not a collection of copies, but a hierarchy of distinct worlds linked by one giant host. The achievement is not merely that Saturn has many moons. The deeper truth is that Saturn has become the organizing power of a miniature planetary ecosystem. And that ecosystem exposes things about formation and evolution that the planet alone could never make obvious. Consider what moons represent in the first place. Some likely form in circumplanetary material around the young giant planet, analogous in a reduced way to planets forming around a star. Others may be altered by later collisions, resonances, or capture events. Still others may preserve records of the early solar system in compositions and surface histories that differ from the main planet and from one another. Each moon is therefore not just an object in orbit, but an archive. Some record the conditions of formation. Some record the later violence of impacts and rearrangement. Some record the long-term influence of tides' orbital resonance and internal heating. Around Saturn, these records do not agree into simplicity. They diversify into a richer narrative. The ringed giant is not merely surrounded by worlds, it is explained by them. The rings, for example, stop being just rings once the moons enter the story fully. Tiny moons embedded near ring edges shape narrow structures. Resonances with larger moons create gaps, waves, and constraints. Debris and satellites begin to look like parts of one larger conversation rather than separate features. Saturn's system teaches that the line between moon and ring material is not always emotionally or even historically as sharp as the human mind wants it to be. Under the right conditions, matter can gather into a moon, be prevented from doing so, be shattered back into debris, or continue orbiting in intermediate states of organization. The moons do not sit outside the ring story. They deepen it. They make the rings look less like decoration and more like one chapter in a much larger history of formation, disruption, and control. And then there is scale. Saturn's gravity reaches across enormous distances, but it does not produce sameness. This is what makes the moon system so revealing. A single giant planet can preside over radically different outcomes depending on local conditions. One moon can be airless and scarred, another bright and fractured, another active, another smothered in haze, another locked into resonances that slowly reshape its interior over geologic time. Saturn, in this sense, behaves less like a solitary world and more like a governing center whose influence generates diversity rather than uniformity. That should not happen if giant planets are understood only as oversized spheres of gas. It makes perfect sense if they are understood as system builders. Saturn's true grandeur, then, is not only that it is large, it is that it creates a domain in which multiple kinds of worlds become possible. This is the deeper reversal. At first, Saturn seems like a singular icon with a few lesser bodies around it. Then the moons accumulate meaning. The observer begins to notice that the ring system depends on them, that orbital dynamics are full of their signatures, that the most scientifically provocative environments in Saturn's realm may exist on those smaller worlds, rather than in the visible atmosphere of the planet itself. Saturn stops being a central spectacle and becomes an engine of context. The planet is still the anchor, but the story is no longer about one body. It is about relationships. Gravity binds the family. Tides reshape it. Resonances connect it. Time differentiates it. And once the moons are allowed to matter at full scale, the hierarchy of wonder starts to rearrange itself. Saturn is still the sovereign world of the system, but some of its orbiting companions begin to feel less like appendages and more like alternate realities. That is where the descent grows stranger. Because one of those moons does not merely enrich Saturn's story. It mirrors pieces of Earth in alien form, carrying atmosphere, weather rivers, lakes, and climate under conditions so different that it turns familiarity itself into a shock. And with that, the center of attention shifts outward from the ringed giant to Titan, a moon so large and so conceptually unsettling that it forces a new question altogether. Whether Saturn's greatest wonder is not the planet that commands the system, but the world nearby that reinvents the idea of what a living-looking landscape can be when the chemistry of habitability is replaced by something colder, darker, and no less profound. Titan is one of the most unsettling worlds in the solar system because it feels familiar for all the wrong reasons. If Saturn's rings seduce through beauty, Titan destabilizes through resemblance. The obvious explanation is that Titan is simply a large icy moon, another cold satellite circling a giant planet in the dark outer reaches beyond the warmth of Earth. The real explanation is more disorienting. Titan is a place where landscapes begin to echo Earth, while the chemistry beneath them turns alien. It has an atmosphere, it has weather, it has winds, clouds, rain rivers, lakes, seas, shorelines, erosion and seasonal change. Yet almost none of these things are built from the materials the human mind expects. On Titan, the role played on Earth by liquid water is at the surface largely taken by liquid methane and ethane. The result is not just a strange moon. It is a second version of planetary process, written in colder substances, dimmer light, slower energy, and conditions that force the meaning of habitability, familiarity, and worldhood itself to widen. This only looks like a moon from a distance. In conceptual terms, Titan is a rival idea of what an active landscape can be. That is why Titan matters so much. It breaks a quiet assumption many people carry without noticing. They imagine that Earth-like surface complexity must depend on Earth-like ingredients. Rivers imply water. Rain implies a warm hydrological cycle. Dense atmosphere implies a planet, not a moon. Titan tears through those connections. It is larger than the planet Mercury, yet it is not a planet. It carries a thick atmosphere dominated by nitrogen, making it the only moon in the solar system with a surface atmosphere denser than Earth's. But the temperatures are so low, around -179 degrees Celsius, that water there behaves less like a fluid and more like rock. The materials switch roles. Ice becomes bedrock. Hydrocarbons become weather. What is solid on Earth can be vapor or liquid there. What is life-friendly here becomes rigid and inert there. The familiar picture survives. The familiar chemistry does not. This inversion is not a curiosity. It is the central intellectual shock of Titan. It teaches that planetary processes are more abstract than human intuition allows. Rain does not belong to water alone. Rivers do not belong to one molecule. Seas do not require sunlight strong enough to warm a blue planet into biological abundance. Under the right pressure and temperature, a world can run a climate system with entirely different working fluids. Titan is the proof. Its methane and ethane cycle through atmosphere and surface in a way that invites comparison to Earth's water cycle, though the comparison must be handled carefully. The worlds are not twins. Titan's sunlight is weak, its chemistry slower, its environmental conditions severe beyond human tolerance. Yet the resemblance is not superficial. Radar and imaging have revealed branching channels carved across its surface. Dark lakes and seas pooled near the poles and regions shaped by rainfall runoff. Evaporation and infiltration into the ground. There are even vast dune fields near the equator, long ridges of dark organic material sculpted by winds under an orange sky. This is not a frozen dead sphere. It is a world where atmosphere and surface continue to interact over time. And that means Titan is not important only because it is strange. It is important because it shows that active evolving landscapes can exist much farther from Earth's conditions than older habits of thought would have guessed. Saturn's system becomes larger the moment Titan is taken seriously. The ringed giant ceases to be the main event and becomes the gravitational patron of one of the solar system's most conceptually disruptive worlds. Titan holds the kind of complexity that would already be astonishing around a star as a planet. Around a moon of a giant planet, it becomes almost provocative. It also carries another layer of importance beneath the landscapes. Titan's atmosphere and surface chemistry are rich in organic compounds. Sunlight and energetic particles drive reactions high in the haze, creating complex hydrocarbons and nitrogen-bearing molecules that drift downward and accumulate. This does not mean Titan is alive, and it would be intellectually careless to pretend otherwise. The temperatures are brutally low, and the surface environment is nothing like Earth's biosphere. But the Moon does offer something precious, a natural laboratory for chemistry that may resemble in some broad prebiotic sense pathways relevant to the early history of worlds. Not a second Earth, not a hidden forest beneath the haze. Something more disciplined and in a way more interesting, a chemically active environment where complexity emerges without needing to resemble home. There may even be a hidden ocean of liquid water beneath Titan's icy crust, mixed perhaps with ammonia, kept from freezing solid by internal heat and tidal effects. If so, Titan holds yet another inversion. At the surface, water is stone and methane flows. Deep below, water may return as ocean beneath a shell hard as rock. One moon contains two incompatible-looking worlds, stacked together, an alien hydrocarbon climate above, and a possible buried water realm below. Saturn does not merely host diverse moons, it hosts moons that seem to contradict themselves. Titan is the largest example of that principle, and the emotional effect is powerful. It makes the solar system feel less like a clean hierarchy of worlds, and more like a library of alternate physical arrangements in which familiar patterns can reappear with different materials and different meanings. Yet, even Titan does not finish the argument. It expands it. Because if Titan shows that a moon can possess atmosphere, weather, chemistry, and landscape rich enough to rival a planet, then the next question becomes sharper, not calmer. How small can such importance become? How much hidden activity can be compressed into a body far less imposing than Titan? That is where Saturn's system becomes even stranger. One of its lesser moons should by ordinary expectation be a frozen relic, dim, ancient, and geologically spent. Instead, it throws material into space from a hidden ocean beneath ice, turning a small white moon into one of the most consequential places in the search for habitable environments beyond Earth. Titan widens the map. Enceladus breaks it. Enceladus should have been easy to ignore. That is what makes it so dangerous to old assumptions. In a system already crowded with grandeur, with Saturn dominating the sky, Titan carrying seas and weather, and the rings spreading their bright geometry across space, a small icy moon ought to have remained a minor object, one more frozen relic circling in obscurity. The obvious explanation is that significance follows size, that the larger world must contain the deeper possibility, the denser atmosphere, the greater heat, the more plausible stage for anything chemically or geologically interesting. Enceladus breaks that logic cleanly. It is only about 500 kilometers across, far smaller than Titan, far smaller than Earth's moon, and by simple expectation, it should have cooled, hardened, and fallen silent long ago. Instead, it is active. It vents material from beneath its icy crust into space. It sends towering plumes of water vapor, ice grains, salts, and organic compounds outward through fractures near its south pole. It feeds Saturn's E-ring with its own escaping material. It turns emptiness into evidence. And with that single reversal, Enceladus becomes one of the most consequential worlds in the solar system, not because it is large, but because it reveals that even a small moon can hide an ocean and communicate with space directly. This is the point where Saturn's system stops being merely beautiful or merely diverse and becomes scientifically urgent. For a long time, the standard intuition about little icy moons was simple. Small worlds cool fast. Without enough mass, they lose internal heat, geological vigor declines, and the body becomes a record of the past rather than a participant in the present. That expectation is often reasonable. It is also incomplete. What matters is not size alone. It is the system beneath size. Enceladus is not active in defiance of physics. It is active because orbital dynamics, internal structure, and tidal stress combine to keep the interior from freezing into total silence. Saturn's gravity pulls on the Moon. Neighboring moons, especially through orbital resonances, help maintain a slight eccentricity in Enceladus's orbit. That means the tidal force is not constant. It changes as the Moon moves closer and farther in its path, flexing the interior over and over. A rigid world resists. A layered world bends. Bending generates heat. Heat preserves liquid. Liquid changes the future of the Moon. The story on the surface is a white, icy sphere with scars. The story underneath is a body being worked from within by gravitational strain until it refuses the fate that size alone seemed to assign it. The fractures near Enceladus's south pole, informally called tiger stripes, are among the clearest signs that the Moon is not asleep. These long cracks are not passive marks. They are gateways, warm relative to the surrounding terrain. They are places where the hidden ocean below can communicate with the vacuum above. Through them, the Moon vents material into space in immense cryovolcanic plumes. That phrase, cryovolcanism, sounds like a cold imitation of ordinary volcanic activity. But on Enceladus, the phenomenon is not secondary. It is revelatory. A moon that should be sealed is leaking. A moon that should be frozen through is exchanging material between an internal sea and open space. A moon that should have required deep drilling to study instead offers samples, freely hurling them outward where spacecraft can pass through and examine them. The achievement is real. The implication is larger. Enceladus does not merely possess a hidden ocean, it makes that ocean legible. This is why the Moon matters far beyond Saturn. Oceans beneath ice are not unique in concept. Several icy worlds in the outer solar system are suspected to hide them. What makes Enceladus extraordinary is accessibility. The ocean is not buried in perfect secrecy. Salty grains, silica particles, molecular hydrogen, carbon-bearing compounds, and other materials linked to internal processes have been detected in the plume material, pointing toward an ocean in contact with a rocky core where water and rock interact under warm conditions. That detail changes everything. An ocean alone is intriguing. An ocean in contact with rock is more than intriguing. It suggests chemistry gradients exchange and possible energy sources of the sort that on Earth become profoundly important in environments where life does not depend directly on sunlight. It would be reckless to claim more than the evidence allows. Enceladus is not known to be inhabited. No organism has been found there. The Moon remains a place of disciplined possibility, not convenient fantasy. But possibility on this scale is enough. It means a small world orbiting a giant planet in the outer solar system may contain liquid water, chemical ingredients, and internal energy in one connected environment. The old map of where significance belongs no longer survives intact after that. Saturn's family becomes more than a collection of beautiful satellites. It becomes a set of experiments in planetary potential, and Enceladus sharpens the meaning of that transformation. Titan expands our imagination outward by showing that a moon can carry atmosphere weather and alien surface cycles. Enceladus drives inward by showing that beneath a bright icy shell there can be warmth exchange and a hidden sea under pressure. One moon broadens the visible surface of possibility. The other reveals a buried one. Together, they force Saturn's system to be read, not as a remote museum of frozen leftovers, but as an active realm where different pathways to complexity remain open. Even the scale of Enceladus becomes part of the lesson. It is small enough to make its activity feel implausible, and precisely for that reason, it is devastating to lazy hierarchies of importance. Size matters, but context matters more. Orbital resonance matters. Tidal forcing matters. Internal layering matters. A moon does not need to dominate a system to overturn its meaning. It only needs to reveal that hidden habitability or something approaching it can persist where older expectations predicted dead ice. And once Enceladus has made that case, Saturn itself changes once more. The rings become less final. The planet becomes less central. The system begins to look like a network of exchanges powered by gravity, maintained by motion, and paid for through strain. Nothing in Saturn's realm is simply preserved. The elegance is real, but it is purchased through pressure, orbital control, tidal flexing, fracture leakage, and loss. That is the next door opening beneath the moon's white surface. Enceladus does not merely add wonder to Saturn's domain. It exposes the cost beneath the order, and from here, the story must widen again from remarkable worlds to the deeper physics that keeps them active by turning harmony itself into a form of slow damage. Saturn's system looks harmonious because the damage is spread across time. Human beings are easily deceived by arrangements that persist. If the moons keep orbiting, if the rings remain bright, if the geometry appears clean, then the mind assumes peace. But orbital order is not peace. It is often the visible result of forces that never stop extracting a price. The obvious explanation is that Saturn's family of rings and moons has settled into a balance in which each object keeps to its lane and the whole arrangement endures because it is stable. The real explanation is harsher. Saturn's order is maintained through stress resonance, fracture heating, leakage, and loss. The system works not because nothing is being spent, but because everything is being spent slowly enough to look serene. This is where Saturn becomes one of the clearest lessons in how beauty can be the visible form of ongoing damage. Start with tides, because tides are the tax collector of gravitational systems. Whenever one body pulls more strongly on the near side of another than on the far side, it stretches that body. Slight eccentricities, layered interiors, and changing distances mean that the stretching varies through time. A moon flexes, ice cracks, rock grinds. Internal friction converts orbital energy into heat. That heat can preserve oceans, power plumes, and delay geological death. It can also alter the orbit and distribute stress through the crust. Enceladus is the clearest example, but it is not the only one. The lesson is general. In Saturn's realm, activity is often the child of strain. A moon becomes interesting because gravity refuses to leave it alone. The achievement is real. The cost is mechanical. Resonance deepens the price. Resonance sounds abstract, elegant, a mathematical relation between orbital periods. Yet in planetary systems, resonance is one of the ways gravity turns repetition into consequence. When moons fall into commensurate orbital relationships, they can tug on one another, rhythmically reinforcing eccentricities that would otherwise fade away. Instead of letting motions settle into easier paths, resonance can preserve instability, just enough to keep tides active. That can maintain internal heating for immense spans of time. But once again, the resulting wonder must not be confused with gentleness. If a moon remains geologically active because another object keeps nudging its orbit away from perfect circular calm, then every geyser, every cracked plain, every hidden ocean owes part of its existence to a long campaign of controlled disruption. Some interactions carve structure into the rings. Some preserve internal heat in moons. Some slowly move objects outward. The system does not merely contain bodies, it scripts interactions, and interactions over geologic time become forms of wear. Even the rings survive through costly discipline. Ring particles collide and trade momentum. Embedded moons disturb them. Larger moons sculpt edges through repeated gravitational influence. Gaps open not because space is cleanly empty, but because repeated forcing organizes matter into some places and removes it from others. Waves propagate through the ring material like signatures of invisible pressure. Dust is generated. Ice is exposed, darkened, buried, and renewed. Material drifts. Some of it spreads outward, some of it falls inward. The rings look like symmetry. In reality, they are maintenance. They are what debris looks like when gravity and collision have spent ages sorting it without ever granting it rest. Saturn's moons also remind us that preservation is not a gentle concept in physics. To hold a moon is to dominate its trajectory. To keep a family of satellites over billions of years is not to offer them peace, but to bind them inside an environment where their futures are constantly shaped by the host planet's gravity and by one another. Some moons preserve ancient surfaces because they are cold and distant enough to avoid deeper alteration. Others are transformed because they were not allowed that stillness. The system therefore contains both archives and casualties. Some worlds are scarred by impacts from debris that Saturn's gravity helps redirect. Some small moons near the rings look less like sovereign worlds than like survivors of repeated rearrangement. This is another emotional reversal Saturn forces on the observer. The system appears tiered planet rings moons, but underneath that hierarchy lies a long history of exchange in which matter has moved between categories. Debris can become moonlets. Moon material can become debris. Ring particles can be shepherded, scattered, or consumed. The boundaries are meaningful, but they are not sacred. Time keeps negotiating them. That negotiation reaches inward to Saturn itself. The planet is not a passive anchor while all change happens around it. Saturn raises tides on its moons. Yes, but the moons raise tides on Saturn too. And through those interactions, orbital energy can be redistributed. Some moons slowly migrate outward over long timescales as angular momentum is transferred. The central planet participates in the same economy of force that governs its dependence. The system is not a sculpture with Saturn at the center. It is a power network with Saturn as its largest node. And all power networks develop losses. Order in celestial mechanics is often expensive. A moon stays active because it is flexed. A ring remains sharp because particles are constrained and sacrificed. A resonance persists because bodies keep pulling one another away from simpler states. Saturn's beauty, therefore, does not sit above damage as an innocent aesthetic layer. It emerges from a regime in which damage is one of the operating principles. The rings shine because they are made of broken material that could not become whole. Enceladus lives geologically because it is under stress. Titan's orbit exists inside a larger architecture Saturn maintains through mass and time. Harmony is real, but harmony here means a choreography of expenditures so slow that human lifetimes mistake them for stillness. That is the hardest reframing in Saturn's story. The system is not preserved from change by its balance. It is changed by its balance continuously. And once that becomes visible, one final illusion begins to collapse with it. Saturn no longer looks like a finished arrangement. It starts to look like a temporary configuration inside a much longer history of assembly disruption migration and loss, a snapshot so beautiful because it is caught between what has already been broken and what has not yet disappeared. Saturn feels eternal because the human eye enters the story too late and leaves too early. We see the planet in a moment of extraordinary coherence and mistake that moment for permanence. The rings span outward in luminous balance. The moons keep their distances with enough regularity to look ordained. Everything about the scene invites the wrong conclusion. The obvious explanation is that Saturn represents one of the finished masterpieces of the solar system, a stable outer monument that has long since settled into its final form. The real explanation is larger in time and less forgiving. Saturn is not a completed arrangement. It is a temporary configuration inside a history of formation, migration, disruption, erosion, and loss that began long before human beings existed and will continue long after every human memory of the planet is gone. The calm image is real, but it is only a frame cut from a moving process. To see Saturn clearly is to see a system caught in passing. Planetary systems do not begin as polished diagrams. They begin as disks, collisions, gradients, and competition. Matter gathers where it can fails, where it must migrates, when forces allow and survives, only if later violence does not undo earlier success. Saturn carries that history within it. Its deep interior remembers early accumulation beyond the frost line. Its mass remembers the short-lived gas disk that had to be exploited before dispersal made giant formation impossible. Its present orbit may not be the exact place where its decisive growth began. Its moons remember impacts, tidal reshaping, and resonances that changed over time. Its rings may remember the destruction of a moon, or the disruption of icy bodies that wandered too close. Every major feature of Saturn's realm points backward toward a past in which the system was less orderly, more violent, and far less recognizable than the elegant scene now presented to the eye. The story on the surface is a world that simply is. The deeper truth is a world assembled out of many things that no longer are. That distinction becomes sharper when time is allowed to keep moving. Saturn's rings are not frozen in their present state for the indefinite future. Their material is being redistributed, darkened ground down, and in part lost to the planet below. Ring rain drains the spectacle inward. Collisions change particle sizes and local brightness. Moons preserve some structure while also helping process the debris endlessly. Even if the rings persist in altered form for a long time, the broad, bright rings that define Saturn in the human imagination are not guaranteed to endure as they are. They are a phase. Saturn without these rings is still Saturn. Saturn with these rings is a temporary edition of Saturn, and humanity happens to live during it. The moons are temporary in their own ways too, though their changes are measured on scales that dwarf human history. Tidal interactions shift orbital distances. Resonances can strengthen, weaken, capture, or release bodies over immense durations. Internal oceans may persist for ages and then freeze. Plumes may wane. Crusts may thicken. Surfaces may be renewed or left to accumulate scars. Titan's methane cycle is not a universal constant. It is the product of present conditions, atmospheric inventories, solar input, and chemical replenishment, all of which belong to a particular era in that moon's existence. Enceladus's activity is not an entitlement. It is a state maintained by energy flow and orbital circumstances that themselves are part of a longer evolution. A moon can be extraordinary and still be temporary. In Saturn's system, that is almost the rule. What seems settled is often only slowly unfolding. Even Saturn's role in the solar system has a temporal dimension that resists static thinking. The giant planets are not just large bodies parked at the edge of an eternal blueprint. Their formation and migration likely helped shape the distribution of smaller bodies, influencing where debris accumulated, where impacts became common, and how later architecture emerged. Saturn therefore belongs not only to its own history, but to the history of the solar system's arrangement. It may have participated in early migrations that reconfigured outer regions. It continues to influence populations of smaller objects through gravity. Saturn is a survivor of system building, but also an actor in the continuing consequences of that building. Worlds do not merely endure, they continue to make futures around themselves. The emotional force of this realization is easy to underestimate, because celestial timescales are so vast that change can hide inside apparent stability. Rings around Saturn evolve slowly enough that the eye can believe in eternity. But permanence is often just slowness beyond human scale. Saturn teaches that lesson with unusual clarity. A system can remain orderly for millions of years and still be transient in the language of physics. A ring can seem immortal and still be thinning. A moon can harbor an ocean for ages and still occupy only one viable interval in a longer thermal decline. A giant planet can dominate the sky while quietly radiating away its internal heat, settling and transforming from within. Time does not need to move quickly to be decisive. It only needs to keep moving. This is the point at which Saturn becomes larger than astronomy posters ever suggested. It is no longer just the most beautiful planet. It becomes one of the clearest demonstrations that cosmic order is often an intermediate state rather than a final one. Systems do not have to be collapsing visibly to be temporary. They can be exquisite, coherent, and already in the process of being lost. Saturn's grandeur depends on this truth. The rings are meaningful because they are not eternal. The active moons are meaningful because their activity is conditional. The whole system becomes more astonishing once it is understood as a snapshot taken during a rare and changing configuration. Beauty is not weakened by transience here. It is intensified by it. And that prepares the final turn, because once Saturn is understood as a temporary arrangement rather than an eternal symbol, the last question is no longer whether its beauty is real. It is whether beauty of this scale draws part of its power from the fact that it cannot last, and whether Saturn is unforgettable not despite its impermanence, but because its most magnificent features are already on their way to disappearing. Saturn is unforgettable, not because it defeats time, but because it reveals what time does to beauty when beauty is allowed to remain visible. At the beginning, the planet looks like perfection, a pale globe, a flawless ring, a geometry so balanced that it seems almost detached from history. That first impression is powerful, and it is not wrong exactly. It is incomplete. The obvious explanation is that Saturn moves us because it is one of the solar system's most elegant objects, a world whose symmetry feels so pure that it rises above ordinary planetary disorder. The real explanation cuts deeper. Saturn moves us because its elegance is temporary, because the symmetry is underwritten by instability, because the rings are not an eternal crown, but a fragile arrangement of broken ice, because the moons are not decorative but active burdened worlds, and because the whole system is caught in a moment where order and loss are both visible at once. Saturn is not merely beautiful. Saturn is beauty under deadline. That is why it lingers in the imagination more forcefully than many larger, hotter, or more violent things. It does not simply impress the mind with scale. It confronts the mind with transience made majestic. Human beings are not neutral observers of time. We crave forms that appear finished. We are drawn to circles, balance, recurrence, and visible order because they feel like relief from decay. Saturn offers all of that at first glance. Then it withdraws the promise. The rings are thinning, falling, eroding, and being reworked. The moons carry hidden oceans only because they are flexed and heated by constant gravitational strain. Titan's seas and weather belong to a particular chemical and climatic interval, not to some guaranteed forever. Enceladus shines with significance because it is leaking the evidence of a hidden world into space. And leakage is never the language of permanence. Even Saturn itself radiates the memory of formation outward while slowly settling, slowly cooling, slowly changing from within. The calm image remains. The certainty beneath it does not. This is the final reversal Saturn imposes. What first looks like the solar system's most timeless object turns out to be one of its clearest demonstrations that time does not need chaos to leave a mark. It can work through order, it can work through rhythm, it can work through the patient spending of structures too large for human lifetimes to notice breaking. That changes the meaning of the whole system. Saturn is not a monument standing outside history. It is history made visible in the form of a monument. The rings are the clearest example. They are what made Saturn famous, the feature that turned a distant giant into a universal symbol, and they now stand revealed as a luminous act of loss. Whether they arose from a moon torn apart, a cometary disruption, or a more complicated sequence of events, they exist because something failed to remain whole. They endure because debris can orbit. They shine because ice reflects light. They matter because they will not last. The achievement is real. The meaning is larger. Saturn's greatest visual gift is not a sign of exemption from change, but proof that change can arrange broken material into something so coherent that it looks eternal until understanding arrives. The moons deepen the lesson. Titan and Enceladus are not just scientific curiosities orbiting a more important planet. They are alternative answers to one of the oldest questions in planetary thought. What kinds of worlds can remain active, layered, and chemically interesting in the cold Titan answers at the surface, with atmosphere, weather, rivers, lakes, and a climate built from the wrong liquids under the right conditions? Enceladus answers from below with a hidden ocean, plumes, salts, organics, and evidence that even a small icy moon can refuse geological silence if the system around it keeps working on it hard enough. Around Saturn, significance is distributed rather than centralized. The giant planet governs the system, but the system returns meaning to the planet. The rings reveal broken order. Titan reveals parallel process. Enceladus reveals buried possibility. Together, they transform Saturn from an object into an argument. They argue that worlds are not important only because of size, temperature, or proximity to sunlight. They are important because of structure, interaction, timing, and the ways energy keeps moving through them. And timing, in the end, may be the deepest thread connecting everything Saturn is. Saturn forms in time before the gas disk vanishes. It gathers a vast atmosphere because it crosses a threshold before the window closes. It wears bright rings because debris remains trapped in orbit during this era. It presides over active moons because tidal relationships still spend orbital energy into heat. It appears serene because human observers exist during an interval in which the system's losses are slow enough to masquerade as permanence. take away timing, and the grandeur changes. See the system too early, and the beauty has not assembled. See it too late, and the rings have faded, the leaks have changed. The present balance has moved on. Saturn is not just a place, it is a fortunate visibility. That may be the deepest reason the planet feels almost emotional to look at, even for people with no formal interest in astronomy. Saturn presents the rare spectacle of impermanence at a scale large enough to feel cosmic and orderly enough to feel intimate. It reminds the observer that the universe does not save its finest arrangements by making them permanent. Sometimes it lets them become magnificent precisely by making them temporary. A ring system can be unforgettable because it is dying. A moon can be precious because it is under strain. A planet can become iconic because its most recognizable features are neither original nor final, but passing through a configuration that briefly allows minds like ours to see them. In that sense, Saturn is not just the ringed planet. It is the solar system's clearest lesson that transience does not weaken wonder. It completes it. And once that truth is fully visible, only one final movement remains, not to add another fact, but to step back from the system as a whole and let its larger meaning settle into place. Saturn begins as an image and ends as a revelation. At first, it seems to offer the oldest comfort in astronomy, the belief that somewhere in the cold, beyond the noise and fracture of smaller lives, there exists a world shaped like permanence itself. A perfect globe, a perfect ring. A system so poised that it feels exempt from the usual cost of becoming. But Saturn does not keep that illusion for long. The closer the mind moves, the more the symmetry opens into history. The rings are not eternal adornment, but broken ice held in temporary order. The moons are not silent companions, but worlds under pressure, leaking oceans, holding seas, carrying the slow consequences of gravity across immense spans of time. The planet itself is not a finished object, but a layered survivor of timing, formation, migration, and internal change. That is what makes Saturn larger than its image. It is not merely beautiful. It is beauty made out of things that do not last. Its grandeur is inseparable from erosion. Its calm is inseparable from motion. Its balance is inseparable from strain. The whole system stands as a reminder that the universe does not reserve wonder for what is permanent. Sometimes it gives its greatest force to arrangements already passing away. And that may be why Saturn endures so powerfully in human thought. Not because it escapes time, but because it lets time become visible without destroying grace. It shows that loss and splendor are not opposites at all. In the largest systems, they can be the same event seen from different distances. Saturn shines because it is changing. It matters because it is temporary. And in that light, the ringed planet becomes something more than a distant giant. It becomes one of the clearest truths the solar system can offer, that the most unforgettable things in the universe are often the ones already on their way to disappearing.